Actually, I've got a molecule here sitting right in front of me. So it's that oxygen in the middle. So oxygen, two carbons, and hydrogens on the outside. Because it's got that oxygen in the middle, when it burns, it doesn't generate any particulate matter. There's something on the order of 26,000 power units in the rail system. Even you said like, okay, we're going to spend however much money to replace all of the power units with all 26,000 with hydrogen power. We don't even have a solution that we could put in place.
Hello, everybody. Welcome to Asset Life. I'm your host, and our guest today is Elliot Anise-Hicks from Oberon Fuels. Hi, Elliot. How are you?
I'm doing well. Good to see you, Oz.
See you. Thanks for joining us. All right, I'm gonna take you back to memory lane. 1994, you're at MIT racing a solar power car in the Tour de Sol. That sounds actually pretty fun and cool. What was going through your mind back then? Is that the same itch that has followed you in your 30-year career?
It is, and I'll actually go back a little bit further. The whole reason that I ended up at MIT was I grew up in a very small town in Western Canada, and when I was starting to think about college, I was reading an article in Popular Science that talked about a solar car race across Australia that was won by a team from MIT, and I'd never heard of MIT before. So I asked my mom about it. I was like, "What's MIT?" And she was like, "I don't know." So I was like, "It might
I
be an
don't know.
interesting place to go. Like, because it's like solar car thing." And I think it's like really interesting. I think like like the sort of gasoline and like the traditional way that we power vehicles is like we need to get to a sustainable future and like innovating on how we move around. And one of the fundamental things about what we do is really important and like a really like thing that I was really interested in and passionate about. So this is actually pre-internet, at least where I was growing up. It was still pre-internet. So she told me to go down to the library to get the address so I could write away for information. So I did that. I go down to the library. I was like, "Can I get the address for MIT?" And they're like, "What is that?" And I was like, "I don't know." So
I
I
don't
was
know.
like, "It might be Michigan Institute of Technology." And they're like, "We'll check." So they went. They couldn't find that, but they found Massachusetts Institute of Technology, and we're like, "Might that be it?" And I was like, "That might be it." So I wrote away to that one. So that started my journey, and I was excited to join the solar car team when I got to MIT, and I was a small part of the team, and we had a cool little commuter class sort of vehicle. So it had like it was side by side seats in it. It was very funky little vehicle. So it was a lot of fun to be part of that and to work on that. It was very avant-garde. It wasn't kind of like ready to go out on the streets. The whole electric car industry has really moved, and technology has really moved a tremendous amount over time. But I think that there's both what was partly fun about that was the how innovative and different it was and like taking a new approach. But also I think that there's a real need for things that are practical in terms of solutions. So that kind of tied into to Oberon. And Oberon came around years later, the opportunity to step into that. The opportunity to come up with a new way of producing fuel to move cars that was sustainable and kind of met those criteria was really exciting. So it really felt like it was coming home to what was initially passionate when I was a teenager reading Popular Science magazine back in Canada. So it really came around.
That's really cool. Let's talk about that. Let's talk about Oberon. I don't think a lot of people are familiar with renewable DME. And would you mind just taking us to what's that and why it's important for our lifestyle?
Sure. So DME itself has been around for a long time. I mean, it's been used for over a century in different applications, and it's a very versatile molecule. It can be used as an aerosol propellant. It can be used as a refrigerant, and it can also be used as a diesel replacement. And when Oberon first started, we really, at the very outset, we were looking at biogas as an underutilized resource, going to gasoline in order to get to a liquid fuel. So that was the initial impetus. Getting to gasoline really required riskier technology than was currently available, and we weren't really going to get there. But if you looked at the sort of established processes for getting like methanol to olefins technology, you go through DME along the way, and so like there was a realization that hey, if we stopped at DME, then we're cut out a bunch of the process, and so like this potentially cuts down the cost of getting there. And at the same time, like this was the decision to make DME as a diesel replacement came out in very early 2011, so very early on in Oberon's life. But at that time, uh, emissions requirements on Class 8 trucks, the diesel trucks in North America, had ratcheted up significantly, which was a good thing because you were cutting down on the particulate NOx that was
Yeah.
coming out of the trucks. But it also was showing some of the limitations of conventional diesel as a fuel in terms of the cost of the engines was going up. The emissions control systems were much more expensive, and they were also adding complications to the operational side. In DME, because when it burns, it doesn't generate any particulate matter. I've actually got a molecule here sitting right in front of me. So it's that oxygen in the middle, so oxygen, two carbons, and hydrogens on the outside. Because it's got that oxygen in the middle, when it burns, it doesn't generate any particulate matter. But you still have the same high performance, a high cetane number that you get with diesel. So you're not trading off performance for a cleaner burning fuel. And DME handles very much like propane. So converting a diesel engine to run on DME was about the same as converting a gasoline engine to run on propane or LPG.
Hmm.
So it's a very modest amount of conversion in order to deliver the fuel, but the fuel in the engine was really the same, giving the same performance with all these additional benefits in terms of environmentally, how it was. So that was kind of the start that tied it in, looking at renewable DME as a sustainable fuel option that would also be a better fuel or a good alternative fuel, particular for existing diesel engines.
So what I really like about this approach is that it's a little bit like the oil and gas industry. We have this big equipment, like critical equipment for the production of the products that we use every day, and those are all the equipment that need to be replaced and repaired, and takes millions of dollars and year-long projects. And I love the philosophy of what you're describing. Just use the same engine, the same tank, the same things that you own, but run through it a different through it a flow that's different. Do you think that's a better way of evolving technology like this?
Well, I think that there's always an economic challenge with switching to something different, and it doesn't matter like what it's different that you're switching to. There's always a cost in switching to something else, and then the question is like how much is that? How big is that cost? And with DME, because it handles like propane, you can use propane equipment in order to handle it, to store it, to move it. So there's a lot of existing assets out there that handle the transportation and the moving of it. And then to actually modify a truck or a combine or a heavy piece of mining equipment, like anything that is a diesel engine, you're not looking at swapping out large portions of the vehicle. You're looking at swapping out some hoses and you're putting out a tank, which is a low cost tank.
Mhm.
It's not it's not an insulated tank. It's not cryogenic. It doesn't have to handle 10,000 psi. This is effectively, a propane tank that's going onto a vehicle. So a low cost tank. And then that is being used to feed in. So the infrastructure cost to switch over from conventional diesel to DME is pretty low because we're leveraging the supply chains, the equipment that's out there that's there's already an infrastructure in place that can handle the movement and delivery of DME with very modest tweaks and changes and so on. We had to go through, there's lots of changes on the regulatory side of it, on the
Mm.
getting taxation laws changed and things like that. Like there's lots of things that go into bringing a new fuel in, but the actual cost of implementing a solution with DME is really quite low. And I think that's one of the, when we look at hydrogen and some of the other fuels, like there's great potential. But there's also when you just look at it in terms of putting in new equipment and doing entirely new technologies in order to do it, that can get very expensive and make it challenging. As an example for that, I was part of an industry panel on a call that was looking at ways to decarbonize or lower emissions from the rail system, and it was a very interesting discussion, and looking at hydrogen, like somebody who's worked at one of the major railroads was pointing out that there's something on the order of 26,000 power units in the rail system, and at the time there was you know there was no tinder solution for hauling hydrogen and supplying a chamber with hydrogen. So even you said like, okay, we're going to spend, however much money to replace all of the power units with
Hmm.
all 26,000 with hydrogen power, we don't even have a solution that we could put in place. And then if you
Correct.
get to the point where like okay, spend some time figuring out, okay, what does a hydrogen tinder look like? You develop that, that's all new. Then you have to train people how to use it because it is a totally
Hmm.
different handling mechanism and filling mechanism than the large infrastructure that's already in place. And so it's not that that is an insurmountable challenge, but that is a very difficult thing to do and very expensive, and will take a long time to really to make that kind of a change. Whereas when we can leverage existing infrastructure, make
Exactly.
nobody likes incremental improvements, but incremental improvements also are improvements, and they are ways to that we can economically get things done quickly, and whatever assets we can leverage in order to do things cost effectively and quickly is beneficial. Like, would you rather spend all our focus and energy on just going to hydrogen in the train system, or would you want to maybe work on that while at the same time we work on decarbonizing the diesel that's going into that train system?
Hmm.
I mean, I would take the benefit over, the next couple decades
Correct.
while we get the hydrogen part figured out,
Exactly.
than just
Exactly.
not do
Incremental
anything.
benefits are still benefits. I agree with you
Mhm.
100%. Sometimes we try to do a big bang, and sometimes what moves the needle are those small increments. You see the benefits right away. So I think that's
Yeah.
the right approach of doing it. You spoke about hydrogen, and obviously this is called asset life. So at some point we have to talk about asset. And I was reading that you're building something pretty cool, a reactor that makes clean hydrogen out of your own molecule. What's the gap that you're trying to close with this new innovation?
So with hydrogen, I mean, one of the challenges, obviously, being clean burning is wonderful, and there's the advances being made on how to produce it and getting costs down and so on. There's different ways to do that, um, but moving it and storing it is still quite expensive, and it requires new infrastructure in order to do that. If you're using DME as a carrier molecule effectively in order to transport hydrogen, then you're able to utilize the existing propane infrastructure in order to move it. And
Hmm.
DME and methanol essentially convert in the same conditions to release hydrogen. So both are low temperature options. So the reactor is operating low temperature, quite efficient, quite safe, and also lower cost because you're not operating at close to 1,000 C if you're as you would with a natural gas reformer. So as part of the solution, we can, if we're deploying hydrogen, looking at, okay, what we want to, want to put hydrogen into the transportation industry or into various areas that we're trying to decarbonize, and we want to distribute that. The propane infrastructure that we have, especially in the U.S., is quite extensive and covers the middle of the states. If you if you wanted to do transportation fuel,
Hmm.
and you look at a map of the distribution of the propane infrastructure and where we drive trucks, they overlap quite nicely. Whereas if you look at, say, methanol as an alternative, methanol is great infrastructure, but it's very coastal around the industrial areas, around shipping, and
Okay.
so on. So that doesn't mean you can't use methanol, but when the advantages of DME being non-toxic, being able to leverage the existing propane infrastructure, when you're looking at, okay, do I want to get hydrogen into the middle of the country to an interstate that's going through Missouri or something like that? Like these are these are areas where delivering it with DME can be cost effective, safe, and leverages a lot of the existing infrastructure, both in terms of physical assets and also people that we already have.
Hmm.
We already have people that know how to handle propane. They can handle DME just as well. It's the same skill set.
Transferable, which is also
Mhm.
important because it helps adoption, obviously.
Yep.
Let me go back to something. You and I met at CERAWeek. It was really nice. We had a really good discussion, and something that stuck with me. You said something about the industry is about to get shaken like a snow globe, wreckage from some and openings for others. A lot has transpired since you and I met at CERAWeek. Do you still feel the same? Do you think that some of those things have already initiated, taken place?
Yeah, I think things are clearly shaking out, and it's it's been a lot of projects that were conceived a few years ago are really struggling in the
Hmm.
current environment. Um, and at the same time, I think that the current environment is also highlighting the need for energy resiliency and for energy innovation. So I think that there's both the opportunity for innovation and for an opportunity there at the same time as things are still getting shaken up. And I think like the other side of that is like because things are getting shaken up, there's people that have been doing great work that are also probably available to do new stuff. Like they're not just gonna not do anything. They're gonna go out and find new stuff that works in the current environment and do it. So I think it's it's a uh, I wouldn't say it's a it's exactly a good time, but I think it's an
Hmm.
interesting time, and there will be silver linings that come out of what is a lot of um, not great outcomes with a lot of projects and things that have been under development and the kind of direction we were moving. But I think that kind of also looking globally, um, there continues to be opportunities continue to develop in other places, and like you kind of in some ways the globe is a whack-a-mole. I mean, like you kind of
Hmm.
beat down on a turbine project here, then all of a sudden like someplace else is going to look more attractive, and I think that's happening. So a lot of things that uh, uh, were doing well in the U.S. are moving elsewhere, and some things that wouldn't have been considered previously or maybe getting an opportunity here. So yeah, it's definitely not a time that's calm, but the transition opens opportunities. It always does.
And speaking about opportunities, something I read recently about Oberon, we're gonna find you on the beauty aisle because you have a relationship now, some work with L'Oreal.
Mhm.
How do you find your innovation, your technology moving across verticals like that?
Well, it's interesting. So when we first looked at DME as a diesel fuel, we did some research on DME back in 2010, 2011, and DME has been around for a long time as an aerosol propellant. It was actually, if you go back to the sort of the patent for the modern aerosol can design from the 1920s, it mentions DME as kind of like the example of a good propellant fuel.
Hmm.
And so it's been used a lot for a long time. DME is technically a VOC, so as regulations evolved over time, it lost some favor because of VOC regulations, even though it's a really high quality aerosol propellant. Um,
Hmm.
so what happened a couple years ago was that they realized that the all the non VOC aerosol replacements that had kind of hit the market had a very high global warming potential. So they kind of like they'd
Oh,
hit one problem and then caused another problem with what they were doing. So then they were
yeah.
like, okay, well maybe we should like review like just how strict we are on the VOCs and try and balance things out. And DME is technically a VOC, but in terms of like in terms of smog creation and so on, it doesn't have a significant impact and has a low global warming potential. So it really is a great environmental aerosol. So that's good. At the same time, you've got companies like L'Oreal who have really taken a lead in trying to decarbonize their supply chain, and they are a major consumer of DME. That is a major portion of their DME of their supply chain. So they were really a leader in looking for renewable DME. Well, if you look for renewable DME in the world, you're not going to find a lot of it right now, but you will come
Exactly.
to Oberon pretty quickly. And so Oberon first started producing DME in 2013, switched over to 100% renewable DME production in 2021, but it was fuel grade because again we were initially looking at making a diesel replacement and then blending in with propane in order to lower the carbon intensity of propane. Um, but so the existing plant that we have in California is designed for fuel grade, which doesn't mean that it's low quality. It just means that we didn't scrub out all of the odor. Well, if you want to buy something from L'Oreal, you do not want it to have like some sulfur smell in it or anything like that, which
No.
actually is what you have to have if you're going to be blending it in with propane. So that means we have to do some additional cleanup and switch it over to aerosol production. But L'Oreal really led the way there, but we also got calls out of the blue from companies just they were looking to switch to DME. They were interested in a renewable product as well. There's just more corporate interest in renewable parts of the supply chain, and so Oberon is riding that wave, I'd say, where we're taking advantage of the fact that we can make renewable DME, we already have, and just changing the focus from fuels to aerosol propellants and in that area of the supply chain.
That's an amazing story, and it just shows how innovation sometimes take different paths and different verticals and can be used throughout. So I think that's a very strong story that right there. Just to wrap it up, as I was reading through your resume, you recently changed and moved from CTO to the board. Can you give us some perspective on, like, looking back at your career and this transition and this new position? How do you see yourself as still making an impact in the industry, but through a higher and different position here?
I think it's an interesting time. I mean, 16 years is a long time to be just grinding away day in day out on trying to get something done, and so it's kind of a nice time to step back a little bit. Oberon's really in execution mode in terms of like they know what the plants look like and what the opportunities are, and so in my role as the CTO day to day, I was really more focused on kind of the new technology, integrating new technologies, seeing what was
Hmm.
out there, and so on. And I think that there's a wonderful roadmap of opportunities out there, but it's not really what's needed right now for the company. And at the board level, I can still sort of make the connections to the new technology companies and kind of areas that I think are interesting. There's still lots going on, and I'm excited about that. Being at the board is kind of nice because there's less day to day, there's less a lot less meetings in my life now, which is pretty nice.
Which
I'll
allows
take
you to
that.
do podcasts.
Exactly. Now I'm just doing podcasts, so it's great.
Oh, that's amazing.
Yeah. So no, it's a great shift, and it's a nice time to step back and also just um, I think a lot of times with the day to day, you get caught up in whatever the current fire drill is or whatever the current
Hmm.
focus is, and not having that day to day pressure. I think is also giving some room to think about really what's interesting, what's coming next, kind of take a step back and see how things are evolving and just spend more time thinking, which I think is something that we is easy to get lost in the mix. Is just taking some time to reflect and to ponder. So I'm enjoying that aspect of it.
I think we all want to be like you at some point and enjoy that broader view, have the time to reflect and see the broader picture and not being drilled down, nose down into the day-to-day activities.
Mhm.
That's it for our first episode of Asset Life. Thank you so much, Elliot. Thank you for making the time, and we wish you all the best.
Thank you, Us. It's been a pleasure. Good luck.
Cheers, bye.